Okay, my people, this is the last piece to chapter 1, and it is cubes and cube roots. So hopefully you have understood squares and square roots. Cube and cube roots will be fairly understandable if you understand roots, squares and square roots. So let's start out with a definition. A cube is the product of multiplying a base number 3 times. And if you recall from our last notes, a base is just the number, and then the exponent is how many times we multiply that base number. In this case, it's 3 times. So your example is going to be 2 to the power of 3, or 2 cubed, which is 2 times 2 times 2. 2 times 2 is 4, 4 times 2 is 8. And the word cubed comes from this idea that we start with the square, and when we have a square, we multiply something 2 times 2, which gives us the area or the square, right? It forms a square, it gives us a square. But a cube is the idea of a three-dimensional figure where we have the base times the height times the width. So it's 2 times 2 times 2. And that's why it is called a cube. 2 times 2 times 2. Length times height times width. And that gives us the whole enchilada here, this whole box. How much this whole box would fill. That's the idea of a cube. So a cube root is the number that is multiplied 3 times. Or the base. So if I have 8 and I'm looking for the cube root, it's written as 8 with this radicand sign, which is our square root sign, but it has a little 3 inside of it, or right there at the top. That means the cube root of 8. Here, I'll let you. This sign is called a radicand. So what I want to know is, what is the cube root of 8? What number times itself equals 8? And I do the same thing as I always do. If I make my ladder, I'll do a tree this time as well. Break it down. 2. 2 again. And then instead of putting it into 2 groups over here, these things on the side, or these things that are circled, I make 3 groups because we're multiplying 3 numbers. As you can see here, it would be 2 times 2 times 2 is equal to 8. So the cube root of 8 is 2. That means 2 cubed is 8. And just like we have perfect squares, we have perfect cubes. And again, a perfect cube can only come from a whole number that has been multiplied 3 times. A perfect cube is a cube of a whole number. Another phrase I want to go over very quickly, because you'll be doing problems like this, is a numerical expression. And we'll see this as we go on this year, especially when we get into more algebra. Basically, a numeric expression is a math sentence that uses numbers instead of words. For example, 3 squared plus 4 cubed minus 2. That's a numerical expression. There are numbers in it, and it's not like we have to write it out in words like we practice with decimals. It's just the numbers. Now, the difference between an expression and an equation is that an equation will have an equal sign at the end. You don't always see that in the book. They'll want you to solve it or evaluate it. They'll say, evaluate this numerical expression. That means answer it. They want to know what it equals. When we solve numerical expressions like this, we use the order of operations, which is left to right. And I hope that you did some PEMDAS work last year, which is parentheses, exponents, multiplication and division are together, addition and subtraction are together. And we'll do, like I said, we'll do more of this as the year goes on and as we get into variables. So to solve this problem, 3 squared plus 4 cubed minus 2, we're just going to start with 3 squared. 3 squared is 3 times 3, which is 9, plus 4 cubed, which is 4 times 4 times 4. 4 times 4 is 16, and 16 times 4 is 64, minus 2, and then I do 9 plus 64, which gives me 73, minus 2 equals 71. So you got to go in order. All right, I got to flip my page. So, just to reiterate or to say again, I'm going to draw a cube for us. I start with a square, and then I make a square over it, just a little higher, and I connect the sides. And I have my cube. I'm going to use a highlighter. I'm going to highlight the back part of this cube. The reason I'm highlighting the back part of that cube is to show you that that is a square, and that square would be 6 times 6, in this scenario. And so the area of that square is 6 times 6, which is 36. I'm going to add the width on the side, and that's called volume. And volume is the cube version. It's height times length times width. And length and width are also called base, or length is also called base. It's the bottom part. So let's find the cube, or the volume, of this figure, which is 6 cubed. 6 times 6 times 6. 6 times 6 is 36. 36 times 6. Remember, there's multiple ways to do the math on this. I'll do the standard algorithm. You do it and then see if your answer is the same as mine. You could also do 30 times 6 plus 6 times 6. There's another way to do it. I hope you got 216. Volume. Or the cube of 6. Okay, now we're going to find the cube root. We'll prove it. We're going to prove that the cube root of 216 is 6. Okay, we're gonna undo it. We're gonna undo what we just did, and we're gonna prove it. So 216, 2, 108, 2 again. I hope you're doing this with me instead of not just copying what I have. All right, 2 doesn't go into 27, so we'll go with, I hope you said 3. There's our 1. Now we're going to put it into 3 groups. Group 1, Group 2, Group 3. So how many of each do I have? I have 3 2s and 3 groups, so that's 1, 2 in every group. And I have 3 3s and 3 groups. And then all I want to know is what is the value of one of those groups. So it's all the same number. The cube root of 216 is 6. And we know that because we just did it up here. But now we've proven it. So for practice, I'd like for you to do this. Find the cube root of 64, and then when you come into class tomorrow, we'll discuss it. Break it down like we've been breaking it down. Make equal groups, 3 equal groups. Remember, for squares, it's 2 equal groups. For cubes, it's 3 equal groups. See you tomorrow.